In this example, we are going to graph -5 times the quantity x minus 1 cubed minus 2. So this is a little bit different. We haven't done graphing with transformations of parent functions just yet, but we have graphed polynomials using the behavior at the zeros. So what I would like to do in this example is I would like to graph this example right here using what we know, and then taking everything that we come up with and shifting it down 2 units. This is going to be our introduction to graphing transformations of parent functions, but a little informal. So here, if we were to graph a polynomial function, we would like to factor it first. So if this is all we were given, it really is already factored. Then we would use the zero product property to find the zeros. And to do that, we take our inside of our parenthesis and we set that equal to 0. And in this case, we get x equals 1. So we have a 0 or an x-intercept at 1 if this minus 2 is not there. Then we have to figure out the behavior. That's the only 0, the only x-intercept. Now we have to figure out the behavior at the 0. Because of the 3, the behavior is cubic, and that means that it'll either have a shape like this or it'll have a shape like that. Really, 3, 5, 7, and so on, the odds have a behavior that's something like this. As the powers get bigger, the shape gets a little bit more squared and a little bit more steep, but it's more or less the same kind of shape depending on your ratio of your, axes. So we know it's going to have one of those shapes. So after we do that, we should also perhaps look at so if we do our little steps, factor first fully, zero product property, find the zeros, set equal to 0, and behavior. So that's what we're going to look at. So our leading term, what would the leading term be in this example? Well, -5x to the third. We have an x on the inside, it's raised to the third. It would be definitely an x cubed, and out front we have this -5 being multiplied. The -2 does not impact our leading term. So -5x cubed. So what's the end behavior of this graph? Well, it's very similar to one of the examples we saw recently in another video. It's going to be up on the left and down on the right. Now these arrows are just there to remind me where I'm going. It doesn't mean I have to pass through those in particular. Plot everything, I kind of already did. Multiplicity, how does it behave based on its multiplicity? I kind of already did that too. And now we graph. So if I were to graph this and sketch it a little bit, it's more or less going to have a bit of this shape here. And then over here, it's going to have a very similar shape right there. Okay. But we have this -2. What does that do for us? It takes our entire graph that's already on our paper and moves everything down 2. That's not so bad. So to get our final answer, which will be in the green marker, we would take this graph and move down 1, 2. So that point that was normally a 0 for us, or an x-intercept for us, is now going to be over here. I'm not drawing this quite accurately at the moment. I'm going to show you how you can tighten up the picture in a second. But that is more or less going to be the shape that we're going to be working with. Now, what else can we find? Something else that we can find that can help us figure out the exact stretched out shape of this over here is we can find our x-intercept, or rather a y-intercept. We could also find an x-intercept, but the y-intercept is going to be easier. So how do we get a y-intercept? We fill in 0 for x. 0 minus 1, -1. Cubed, -1. Times 5, or -5 rather. -5 times -1 is 5. -2 is 3. So up over here, this green marker graph should really be going through that point. So it's quite a bit steeper. And if you remember, we did do some examples where we talked about the number in front of our equation and how if it's bigger than 1, it causes a vertical stretch. So really, that's what's going on. So our even better answer, I'm going to do in purple over here. So this point is still here, but now we got to go through here. So if it was more to scale, it's going to be over there. A little scoop has to happen here, and it's going to have the same kind of a shape. Maybe not my best work, sorry. Same kind of shape going down over there. So if we wanted to get a better look at things, what we might do is take our x-axis essentially and stretch that out this way, maybe in Desmos or something like that. But something like this is good enough. If it's multiple choice or matching, this is enough information for you to be able to determine the correct graph going with this equation. I hope you were able to follow the shift down, the discussion about the little stretch over there, and the y-intercept. And good luck if you are going to check out that next example, which should be on the screen right now.